Here we're given a new equation that actually be pretty easy to derive if you want to do that at some point. But um, it gives us the time of flight for an object in the air. And that depends on the initial velocity, acceleration of gravity, and the angle it launches at, right? So here we have a baseball that leaves the bat at a particular speed. And that we have the velocity, we have the angle in degrees, we know g, and so we're just trying to calculate this real quick. All right, so t, time of flight, is going to be time of flight is going to be 2 times the velocity, 2 times 53.42 meters per second divided by 9.81 meters per second squared, times sine of the angle, which is 48.85 degrees. And so there we have our simple little, we just have to perform this calculation. So let's go over to Excel. We have V naught, we have G, and we have theta. So V naught is 53.42, G 9.81, theta is 48.85 degrees. Now, because Excel uses radians and not degrees, the first thing we have to do with this angle is convert it to radians, which we do with the handy radians function. Radians of theta in degrees gives us theta in radians. Now we're ready to calculate time of flight. So 2 times the velocity divided by the acceleration of gravity times the sine of theta. And you should know from the first week now, order of operations is from left to right if the operations are equivalent, like multiplication and division. So Excel is going to do the 2 times this divided by the G6 and calculate all of that and then multiply by the sine of G7. So we get the time of flight. I'm missing a because I put in the wrong, see, you have to have radians. There we go. Time of flight is 8.2 seconds. You see how bad it goes if you don't use radians? 8.201 seconds I'm going to put in. 8.201 seconds. And that's it for this problem.